In a previous video, we have seen that the parallax effect is negligible for any two observers on Earth. If these two observers look at the same star, they will see that the neighboring stars are located in exactly the same position with respect to it, even if located much farther away. This is because the stars are so far that the line of view from the two observers are practically parallel. This allows us to imagine the stars as if painted on a celestial sphere at infinite distance from Earth. Our planet is in the center of this sphere. If we extend our south and north poles and project our equator on this sphere, we can define celestial poles and a celestial equator. This is sufficient to be able to define the position of stars with the equivalent of latitude, as the number of degrees south or north of the celestial equator. This is called the declination. The north celestial pole has a declination of plus 90 degrees. The south celestial pole has a declination of minus 90 degrees. Any point on the celestial equator has a declination of 0 degree. Since the Earth is rotating on its axis, we cannot project the prime meridian to any particular position. We will see how the equivalent of longitude is defined later. Note that this graphic is far from representing the proper scale. The Earth should be no more than a microscopic point in the center of the infinitely far celestial sphere. This is a view of the northern celestial hemisphere. Groups of stars located in specific regions of the celestial sphere form constellations. Constellations have names that often originate from the shape of figures drawn by linking stars with imaginary lines in a certain way. There are 88 such regions covering the whole sky. They have various shapes and size to accommodate the shape and size of the figures drawn by the stars they contain. On a celestial map, regions are akin to state lines, whereas stars are akin to cities, and the arrangement of roads between cities corresponds to the shapes drawn. This is a view from Earth, centered on the north celestial pole. We see that a star from the constellation of Ursa Minor, Polaris, sits practically at the pole. As the Earth rotates on its axis over a 24-hour period, Polaris appears to remain at the same location in the sky, whereas stars that are close to the pole appear to rotate in a tight circle around it. As we move away from the poles, the apparent path of the stars becomes wider and wider. This is a view from Earth of the celestial equator. As the Earth rotates, the stars will rise in the eastern sky and eventually disappear beyond the western horizon. Several constellations become visible, including many associated with astrology. We should note that although the stars are always present in the sky, they can only be observed in the absence of the sun. We will discuss the sun in a coming video.